Okay, ma'am. Welcome to the 23rd class on computer architecture and organization. So, in this class, we are going to 1 minute, discuss, discuss about these arithmetical instructions. So, in the last class, we have discussed about all these things now. Now in this class, we are going to discuss about these arithmetic instructions. Okay, so I think you all are familiar with these kind of arithmetical instructions in your previous classes also. So here, but whatever the arithmetical instructions we have discussed in the previous class are completely different from those what we are going to discuss here, because in this class we are going to discuss these arithmetical instructions as per the PIC microcontroller point of PIC or ARM microprocessor control point of view. So whatever the instructions that we are going to learn, that is related to ARM, Advanced Risk Mission. Okay, so here it will be somewhat different compared to other instruction sets. Okay, but why I am teaching this particular ARM means, see, whenever now you will come to the final year, and whenever you do the projects on our embedded system, the most of the projects as per today, okay, most of the projects we are going to use any microprocessor or microcontroller, those mostly belongs to this ARM only. Okay, though this you are using Raspberry Pi and everything, but still we are using this ARM. So it is one of the latest technology. I don't say it is the latest technology, but it is also, compared to previous versions of 8086 or 8085, 8051, this is somewhat advanced technology. Okay, so here we are going to, first of all, we are going to discuss about the arithmetical instructions. See, the instructions what we are going to learn, those will be different, or those the phenomena or the syntax will be different from those what we have learned previously. Okay, here if you observe carefully, first of all, we are going to discuss the syntax. Okay, the syntax of any instruction will be like this. 1 second. Okay, so the syntax will be like this: opcode, operational code, and so we know that the syntax of an instruction is opcode comma operands. Okay, here if you observe carefully, we don't have two operands, but previously, not in this one, the first unit and second unit, whenever you go through any shift instructions or AND gates, OR gates, whatever it may be, there are only two operands, isn't it or not? One opcode and the two operands. But here, as I have told you in the starting of the lecture itself, as we are discussing with the ARM, okay, here in ARM, the instruction set is somewhat different. It is somewhat advanced, okay, compared to the previous versions what we have learned. Okay, so here we are not having two operands, but we are having three operands. Okay, I think you are all very familiar with the syntax of an instruction, isn't it or not? The syntax of an instruction is opcode space operands. Okay, here if you observe carefully, in this example we are having three operands called RD, RN, RM. We are having three operands named RD, RN, RM. Okay, what is meant by opcode? See, opcode indicates the operation to be performed. That means if I want to make the process to perform add operation, I need to write a code which will be understandable by that particular processor, so that then only it will perform the add operation. If I want to make the processor to perform some shift operation, then I need to write the instruction that is to be understandable by that particular processor, so that it can perform the required shift operation. Isn't it or not? So here the opcode indicates the operation to be performed, and these are the operands. Okay, here we are having three operands. Okay, so that's what here they have told. Here RD, RN, and RM are there now. So these will be these are generally the general purpose registers. General purpose registers means they will be RD, RN, RM means R1, R2, R3, like that. They will be numbered. Okay, so they are used for general purpose. That means for addition, subtraction, multiplication, or shifting of a value, or storing an intermediate value. For all these purposes, the general purpose registers are going to be used. In the name itself, it can specify that they are generally used. Okay, so opcode RD, RN, RM. This is the general syntax. Okay, here Rn and Rm are the general purpose registers. The operation is performed using the operands in the general purpose registers Rn and Rm. Here by using these registers we are going to perform some operation, and the result is going to be stored in the RD. See here, it is entirely different from the previous version, because previously if I have add ax comma bx like that, if I return or add r1 comma r2, if I give some example, then r1 and r2 are going to be added and the result is going to be stored in r1 itself. That means in the previous version, if we have two registers, they two are going to be added or subtracted or multiplied, and the result is going to be stored one among those registers. But here it is not like that. Here if the instruction is given like this, if it is an additional operation, then Rn and Rm are going to be added, and whatever the result that is going to be appeared are going to be obtained, it is going to be stored in the RD. Okay, if it is subtraction, then Rm is going to be subtracted from Rn and the result is going to be stored in the RD. Like that it is going to happen. Okay, 1 minute. So that's what I want to say. Okay, we'll see the next instructions. Yeah, here we are going to discuss about arithmetic instructions. I have a problem with this one. Wait. Yeah, here we are going to discuss about add and subtraction. See, for example, I have taken the example like this: add r0 comma r2 comma r4. This is just like the syntax of the previous one. See, the previous slide, if you observe here, it was mentioned there should be a 3 operands, isn't it? Here also we are having 3 operands. What are those 3 operands? Here it is r0. Okay, this is r0 comma r2 comma r4. Okay, that means as we have discussed in the previous slide itself, here what is the thing that is going to be happened? The value that is contained in the r2 is going to be added with the r4, and whatever the result that will appear, that is going to be stored in the r0. Okay, here I have written in square brackets. It doesn't mean that content or memory location. You just don't think like that. 1 minute, or else I will see what does it means. For example, if here add r0 comma r2 comma r4 is given na. For example, r2 is equal to caps lock. R2 is equal to, you have some 12h, okay, and R4 is equal to some 14h. Okay, whenever you write this operation, these two values are going to be added. If you add these two values, how much you are going to get? 12 plus 14 means 26h. Okay, this 26h is going to be stored in where? Means it is going to be stored in R0. Okay, it is going to be stored in the R0. That means, so whenever I perform this operation, so R0 is equal to how much I am going to get? 26h. This is the way of doing the operations in ARM. Here R2 is 12, and let us assume R2 is equal to 12 and R4 is equal to 14. Then these two values are going to be added, and the result is going to be stored in R0, which was prescribed in the first format. If I write here R6, then these two values are going to be added, and the result is going to be stored in the R6. If I specify some R5, these two are going to be added, and the result is going to be stored in the R5. That is the concept of addition. Similar concept is for subtraction also. See here, once again, please note carefully. I have written R2 and R4 in square brackets. It doesn't mean that they are the memory locations, or else, if possible, 1 minute, and check. If possible, no. Okay, let it be. So these are not the memory locations. That's what I want to say. Okay, next. Here, take one more example. Here, what is the example that they have given? Text. Subtract R0 comma R6 comma R5. Here also the same thing. We are going to subtract the value that is present in R6. Sorry, that is present in R5 from R6. Okay. and whatever the value, whatever the result we are going to store, we are going to get, that particular result is going to be stored in the R0 register. For example, take one example here also. Consider R0 is equal, R6 is equal to, consider R6 is equal to 15H, and R5 is equal to how much will take 0.7H, 0.7, okay, H. If not this one, okay, 0.7H. I am going to subtract these two things. Then what is the answer we are going to get? We need to, okay, if you subtract 15H minus 7, 15 is an hexadecimal number because I have written H. That means its decimal value is how much? 10 means 16, 11 17, 12 18, 13 19, 14 20, 15 21, or 16 plus 5, it will be 21. Okay, so we are going to perform a subtraction of 21 minus 7. Okay, 21 minus 7, so how much we are going to get? 14, isn't it or not? So the answer is 14. 14 will be written as, how we are going to written this 14? 14 will be written as 0E, isn't it or not? 0EH. So this is the subtraction value. R16 is 15, 15. Okay, 15 in the decimal number. If you convert the decimal number, the equivalent of 15 will be 21. Okay. Similarly, 0.7H means its decimal value is also 0.7. When I am performing the subtraction of 21 minus 17, I am going to get 14 as an answer. That 14 is going to be represented in this form as 0EH. In this form as 0EH. So the total answer is 0EH. Okay. As per this concept, that particular answer what we are going to get, it is going to be stored in the R0 register. It is going to be stored in the R0 register. So the value present in R0 is 0EH. Okay. So 0EH is the value that is going to be stored in the R0 register. Okay, so these are the addition and subtraction instructions. Okay, I think it is clear to you now. Next. So for moving to the next instruction, I need to delete this. Okay, next. 1 minute, I will erase. Yeah. Now we are going to discuss, so instead of being contained in the register RM, the second operand can be given in the immediate mode also. So what they are going to tell means, see, we can perform the additions like this also. This is one type of addition. What is the difference between this one and the previous case? You observe carefully, the difference between here and the previous case is, in the previous instruction, all the three operands are registers. But here, if you observe, one of the operand is an immediate value. How can I say it is an immediate value? Means whenever it is followed by hash, okay, we can easily identify that is A17 is a value. Okay, it may be some hexadecimal value, because generally we will write them in a hexadecimal format. Okay, so if you observe here, add R0 comma R3 comma hash 17. What does it mean? Here R3 is going to be added with 17, and whatever the result that is going to be obtained, it is going to be stored in the R0 register. So let us consider that R3 register is having a value of how much will take some 415H. Okay, and as we know that it is going to be added with immediate value called 17H. Okay, 17H. So now I am going to perform the addition. Okay, if I am going to perform the addition, see, 7 plus 5 is 12. 12 in the hexadecimal number. How can I represent? For A it is, for 10 it is A, for 11 B, for 12 it is C, isn't it or not? So here it will be a C, and 1 plus 1 is 2. So the answer will be 2CH. The answer will be 2CH. Okay, this particular 2CH is going to be stored in the result in the register called or not. That's what we have mentioned in our instruction, isn't it or not? Add or not comma r3 comma hash 17. Hash indicates immediate value. That means we are immediately, that means we are directly taking that 17 and we are going to add it with the content of the register r3. We assumed that r3 is equal to 15. Then I have added that 15 and 17. I got 2ch as an answer. This particular 2ch is going to be stored in the register called r0. Okay, so now our r0 contains the value of 2ch. Okay, so this is the concept. This is the another way of giving the operand. That means one of the operand we can specify as immediate value. Okay, the immediate value should be 8-bit. Okay, 8-bit means in hexadecimal we will write with a 2-digit hexadecimal number. I think you all are aware now why it is called 8-bit means if you convert this hexadecimal number into a binary form, used to write 1 as 0001 and 7 as 0111, isn't it or not? So the total number of bits are here, these are 4 bits and these are 4 bits. Altogether the total bits are 8 bits. So this kind of representation is called 8-bit representation. I think you all are aware of this concept, converting of a hexadecimal to binary, whether it is required or not. For representing the each hexadecimal number, for converting each hexadecimal number, we need to represent it in 4 bits. Okay, next. Next, shift and add operation. Here, this is what we will call here multitasking or multiple number of operations are going to be performed in a single instruction. Multiple number of operations are going to be performed in a single instruction in this particular shift and add operation. Here, if you observe, see, there are multiple number of operands. In the previous instructions, we have just discussed about 3 operands. Isn't it or not? In the first and second units, whatever we have discussed, all the instruction consists of only 2 operands. In some instructions, they consist of even 1 operand also. But now, if you observe here we can see 1, 2, 3, 4, 5 operands. Okay, so here in a single instruction, we are going to perform multiple number of tasks. Okay, what are the tasks we are going to perform here is, here we are shifting a particular content, register content, either right side or left side. Okay, we are shifting the value and we are adding that, and after shifting that particular value, you will get some result. Na? You are adding that particular result to a register. You are adding that particular register result to a register. That is what that is going to be happened. So if you observe here carefully, what is this means? Add r0 comma r1 comma r5 comma lsl hash 4. That means first what we need to do is we need to take the rs register. Okay, and we need to shift left that particular contents in this r5 register. We need to shift them left by 4 times, because hash 4 is given here. Hash 4 indicates how many bits how many times we need to shift. For every 1 time we need to shift 1 bit, either right or left. So that means if here hash 4 is mentioned, means we are going to shift that value, we are going to shift 4 times. Okay, that's what they have given here. The second operand which is present in the register r5, it is going to be shifted left by how many times? 4 bit positions, because here hash 4 is given. Hash 4 means it was given as hash 1, so only 1 bit is going to be shifted. Hash 2 times it is going to be shifted. Here they have given hash 4, that indicates it is going to be shifted by 4 times. Okay, so Ama. Okay, so that's what that was given here. Next, see, after shifting this one, we'll get some value. That means we'll get an updated R5 value. That updated R5 value is going to be added with the contents of R1. Okay, and After that, whatever the result you are going to get, that particular result is going to be stored in the R0 register. So overall, this is the concept. Okay. For example, as they are telling now, so just we'll take one example. See, first take R5 is equal to, we'll take some, how much we'll take, 24H. 24 can be written as 0 0 1 0 2 and 4 is 0 1 0 0. Okay, 24H. So I have written, I have converted that particular, I have converted this, 1 minute, just a second. Okay. So I have converted it into a binary format. Now what I need to do, I have to perform logical shift left side shifting. So as it is a logical shift, the positions are going to be empty. Those are going to be replaced with zeros. So after shifting one time, what I am going to get, zeros, 0 1 0 0 1 0 0 0. This is the first thing what I am going to get after shifting one time. Second shift, 1 0 0 1 followed by 4 zeros. Third shift, this one is going to be vanished, 0 0 1 0 0 0 0 0. Next one, 0 1 0 0 0 0 0 0. Next one, 1 0 0 0 0 0 0 0. Okay, that means after performing 4 shifts, see 4 shifts na, this is first one, this is second one, this is third one, this is fourth one. So they, that's this is not required. So what I have got, 40, answer is 40H, isn't it or not? So instead of 24, I got 40H for shifting into logical shift left 4 times. Okay, so this updated value is going to be again stored in the R5. That means previously R5 is 24, but now its value is going to be changed as 40H. So R5 is equal to 45H. Then let us assume that R1 is going to have some value like 12H. Okay, now these two values are going to be added. That means 40 plus 12. What is the value we are going to get? 40 plus 12 is 52H. How much? 52H. This 52H is going to be stored in which register? R0 register. Which register it is going to be stored? It is going to be stored in the R0 register. So the value in the R0 register is equal to 40 plus 12, that is nothing but 52H. How much? 52H. How it is going to be taken place, I will just explain it once again. See, listen carefully. First, what is the thing we need to think is, first of all, we should concentrate in R5. Okay, let us assume that R5 is having value of 25H. Now what is the first thing we need to do? We need to perform shift left by 4 times. Okay, see, whenever you need to perform either shift left or shift right, first of all, what is the first thing you need to do is, you need to convert that particular given value into a binary format. So the binary format for 24H is 0010 0100. This is the binary format. Okay, now I need to perform logical shift left by 4 times. How many times? 4 times. So this is first time. Okay, whenever I perform logical shift left, this particular MSB bit is going to be getting out. Wherever it go means it will go to the carry position. Okay, that we don't bother. Okay, so I will get just one shift. That means 0100 100. That's what we are going to get at the first time. And second time, this one, third time, fourth time. Okay, as they have specified logical shift left by 4 times means I am going to get this value. Its equivalent value is 40H. Okay, so this is the updated value of R5. This is going to be added with R1. Okay, so the value that is contained in the R1, for example, consider R1 is having 12H, then this 40 is going to be added with this 12. So 40 plus 12 is 52H. That 52H is the result. The answer what is obtained, it is going to be stored in the register or not. Okay, so this is the phenomena. Okay, so this is one of the model in the arithmetical addition. Yeah. Next, we are going to discuss about logical instructions. I think you all are very much aware of this one. Logical instructions have the operation which is similar to logical gate. Okay. So you have AND gate, OR gate, NOT gate, like that. Here also we are having AND operation, OR operation, exclusive. EOR means it performs exclusive OR operation. BIC means bit clear operation. I think they given any explanation. Here I have given explanation. No. So we are having AND operation, OR operation, EOR means exclusive OR operation, BIC, bit clear operation. Here if you observe carefully, the previous three operations, you are very much aware of these three operations, because in STLD you have logical gates like AND gate, OR gate, exclusive OR gate, and in the previous units also we have discussed about AND, OR, exclusive OR. Okay, we have it is for us BIC, bit clear operation, is somewhat different one. Okay, whatever it may be, whether we know or not, here the instruction format is as the instruction format is different here, we will learn those AND OR operations once again. Okay, yeah, here it is AND operation. Here, just like the previous operations, here also, if you observe carefully, we are having three operands. Okay, that RD comma RN comma RM. Here the AND operation is going to be performed between the contents of the register RN and RM. Okay, and whatever the answer that is going to be obtained, okay, it is going to be stored in the register RD. That's what that is represented with a what you will call pictorial form. Here RN, what is this one? Intersection RM. Because see, why we have used the intersection symbol means in AND gate the output is going to be 1 if and only if both the inputs are 1, isn't it or not? That means if both the RN and RM both possess the 1, then only the output is going to be 1. The rest cases the output is going to be 0. That means we are performing just like intersection. If the 1 is common in both RN and RM in a particular bit, then only we are getting the answer as 1. That's why we have used this intersection symbol here. Okay, so here we have given one example. Oh, this is big example. We'll take some small example of 8 bits, say like that. Okay, see, let us consider. Yeah, let us consider Rn is equal to some 36H. So if you write this 36H, see one more thing, whenever you perform any arithmetical operations like AND, OR, exclusive or whatever it may be, first and foremost thing what we need to do is you need to convert the given number system into a binary format. You need to convert the given number system into a binary format, then only you need to perform the operation. Okay, here it is given as 36H. 36 can be written as 0011 0110, isn't it or not? This is for 3 and that is for 6. Similarly, take the another register RM. Let us assume its value as some 45H. 45H. Okay, so 45 can be written as 0 1 45. No use na, so we'll just make it as 55. Okay, so 55 means 0101 and 5 means again 0101, isn't it or not? So now we are going to perform the AND operation between Rn and Rm. See, AND operation, I think you all are familiar with the AND gate, na? The output is going to be 1 when both the inputs are 1. In the rest of the cases, the output is going to be 0. Okay, here if you observe, both the inputs are zeros, so output is 0. Next, 0 and 1, 0. Next, 0. Here both the inputs are 1, so output is 1. Similarly, 0, 1, 0, 0. Okay, because here both the inputs are different, so the output is going to be 0. Both the inputs are different, 0. Both the inputs are same, the output is going to be 1. Sorry, not same. If it is same, we are not going to get 1. Both the inputs are 1, so the output is going to be 1. Here one is 0 and another one is 1, so 0. 1 and 0, 0. Here both are zeros, so the output is going to be 0. Here both the inputs are 1, so the output is 1. 1 and 0, so 0. 0 and 1, 0. Both are zeros, so the output is going to be 0. Okay, so this is the way of performing the bitwise AND operation. Here 0, 0, 0, 1 is 1 and 0, 1, 0, 0 is equivalent value is 4. So the total answer what we are going to get is 14H. 14H. Okay, this particular 14H is going to be stored in a register. So it is as per our syntax or as per our instruction, it needs to be stored in a RD register. It needs to be stored in a RD register. So this 14H is going to be stored in our RD register. That's what we are going to do. So RD is equal to 14H. So this is the about AND instruction. This is about AND instruction. Okay, I think it will be sufficient. 1 minute, I will check.